Welcome to Lesson 3.3, Prime Factorization. Today we're going to talk about how to break numbers down into a product of their prime factors. All right, so we've already talked about prime and factors. We know that prime numbers only have factors of 1 in themselves, and factorization, that's when we break numbers down into what they can be divided by and not get a remainder. So what prime factorization is a number written as the product of its prime factors. So basically what you're turning it into is you're turning a number into a multiplication problem. And the numbers in the multiplication problem can only be prime numbers. Okay, so for example, you have 24. 24 can be broken down into 2 times 2 times 2 times 3. Or we can write this, because we've been working with exponents, as 2 to the third power times 3. And now if you work it out, you can see that you end up with 24. So it's not just times random prime factors, it's times prime factors that will give you that number. Notice each of these numbers is prime, and each of them is a factor of 24. All right, so finding the prime factor of factorization of 48. Again, remember what prime means. So only factors, actually only has 2 factors. Okay, and factorization means you're looking for numbers that can divide the number without a remainder. Okay, there's 2 methods. There's a factor tree and there's a ladder diagram, and I'm going to show you both using 48. So the factor tree should end up looking like a tree. So you have 48, and you break it down into any division problem. So let's start with 6 times 8. Since neither of these are prime, we break it down again. 6 can be broken down into 2 times 3. Since both of these are prime, I like to circle my prime numbers and think of them as like ornaments on the tree. It helps me know that, okay, I'm done here. I found my prime factors. Now I can move on to my 8. So here, this breaks down into 2 times 4. 2 is prime, but 4 is not. So I keep going, and I break down the 4. The 4 can be turned into 2 times 2. So the prime factorization of 48, now I have to take these prime numbers and turn them into a multiplication problem. Because what happens is I know that 2 times 2 gives me 4, times 2 gives me 8, and I know that 2 times 3 gives me 6, and 6 times 8 gives me 48. So if I multiply all these prime numbers together, I have to write them in order from least to greatest, so 2 times 2. So there's 1, 2, 3, 4. So times 2 times 2 times 3 is the prime factorization of 48. Or I can write it as 2 to the 4th power times 3. With the ladder method, so with the ladder method, you have to know your prime numbers. So you put 4 in the box, or in the ladder, essentially. And you know that 48 can be divided by 6. Well, that doesn't work for this because 6 is not a prime number. So I usually start working with like 2 and 3. Well, since it's even, it can be divided by 2. And I know 48 divided by 2 is 24. So again, my next prime factor, well, 2 again. So I get 12. And I know that it can be divided by 2 again. So I get 6, which can be divided by 2 again, which I get 3. Now the thing is, yes, 3 is prime, but you have to get your ladder down to 1. So the only number that 3 can be divided by, besides 1, because 1 is what we want to get to, is 3. So my prime factorization is each of these numbers, which turns out to be 2 times 2 times 2 times 2. So look at it this way. 1 times 3 is 3. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So you know it works out. So you get 2 to the 4th power times 3. Again, both answers are the same, just using two different methods. I am going to ask you to use both methods in the video. Then I'm going to ask that when you do your U-tries, I ask that you try both methods and see which one you like better. I'm not requiring you to learn one or the other. I'm giving you both. You can choose your preference. Right? But I would like you to try both because sometimes you end up liking one that you didn't think you would. All right, so here you have 24, 12, and 32, and we're going to use factor trees. So all you're doing is you're breaking it down into the multiplication problem. So I know that this can be turned into 3 times 4. And then I know 4 can be turned into 2 times 2. Each of these is prime. So my prime factorization is 2 times 2 times 3, or 2 squared times 3. Now, what if I had done 2 and 6? This still would have worked. Circled the wrong one there. Because then 6 breaks down into 2 times 3, which gives me my same numbers, just in a different method. Now, I am not going to show you all the ways with every number to get the prime factorization because we would be here for a very, very long time. However, if you would like to try and find the prime factorization of 24 and or 32 on your own and come back and check your work, you're absolutely able to. Just know that you're looking for the end result. If your division or your factors don't match mine to start off, so like if you did 2 and 6 and I did 3 and 4, that's okay. This is what should match. So with 24, I'm going to break it down into, let's see, let's do 12 times, no, I'm not going to do 12 times 2 because I know that this one's going to break down quite a bit and I don't want to start with a prime right off the bat if I don't have to. So let's do 6 and 4. I know 6 isn't prime, but it breaks down into 3 times 2, which both are prime. And I know that 4 breaks down to 2 times 2. So I end up with 2 times 2 times 2 times 3, which is 2 cubed times 3. Interestingly enough, the only difference between this one and this one, so the only difference between the prime factorization of 12 and 24 is an extra 2. Makes sense, doesn't it? Because 12 times 2 is 24. All right, so for 32, I know that 2 times 16 gives me 32. And I know that I can break that down into 2 times 8. And so I have 2 and 2 that are prime. And that breaks down into 2 times 4. And that breaks down into 2 times 2. So I have 1, 2, 3, 4, 5 2's. So I end up with 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. And if you know your powers, you know 2 to the 5th power is 32, so you know it works. All right, so now let's practice using the ladder method. So I'm just going to go ahead and put 18 in there. Why rewrite it if you don't have to? And it's even, so it can be divided by 2, which gives me 9. Now, 9 is not prime, ladies and gentlemen. It can be divided by 3. 3 divided by 3 is 3. I know I need to get down to 1, and the only number that can divide 3 besides 1 is 3. So the prime factorization of 18 is 2 times 3 times 3, or 2 times 3 squared. If you're not sure, double check your work. 2 times 3 times 3. Well, 2 times 3 is 6. 6 times 3 is 18. All right, so I have 100. Do not use 25. 25 is composite, and so is 20. So don't use them. Let's stick with 2 because it works. It's even, so we get 50. And let's stick with 2. I mean, when you can, you might as well stick with 2 because that's the lowest one that you have, and you get 25. Well, now it's not going to work anymore. We know 25 is composite. It can be divided by 5 because it ends with 5. and we get 5. I know 5 is prime, so I know that it has to be 5, and I get 1. So I know that my prime factorization is 2 times 2 times 5 times 5, or 2 squared times 5 squared, which ends up being 4 times 25, which I know if I have 4 quarters, that gives me $1. All right, so that's just double checking our work. 75 is not prime. It's definitely composite. It can be divided by 5 because it ends in 5. Okay, and it can be, so 5 goes into 7 once, and minus 5 is 2, so 25, so it's 15. It can be divided again. Might as well do 5 again because we know it works, and you get 3. 3 can be divided by 3, which gets us to that 1 that we were looking for. So it's 3 times 5 times 5, or 3 times 5 squared. Okay, this really isn't that bad. You just really have to know your prime and composite numbers. And I'm not necessarily worried about turning it into exponential form, but that would be a step that you would want to be able to get to in the future. All right, so you have a couple of you-try problems. Again, I'm asking that you try to use both methods to really make sure that you get that practice. And know that if the number is prime, that it's only going to have 2 numbers to multiply together. Just a little hint there for you. As always, if you have any questions, be sure to email me or write them down so we can go over them in class.